Hi everyone, today we'll be looking at logic, namely just a very brief and introductory overview of statements and arguments. Now, this is very introductory, but it is necessary for at least a very minimal understanding of philosophy arguments. Now, overall today, we'll be going over the following items. At first, we will look at the most simple introduction to logic, namely what is logic and what does it mean when we say the word logic. Second, we will be learning about statements, what the different types of statements are, and we will look very closely at specific types of statements called conditional and biconditional statements. Third, we will move on to what the product of statements are and the item of logic, which would be arguments. We will look at what makes for a valid argument and what makes for a sound one. Here we will also look at some rules of inference and some fallacies often associated with arguments on an introductory level. And at last, I will provide you with multiple different logic exercises to ensure that you're leaving today's video with an understanding of logic at a level that is sufficient to better understand philosophy arguments. So let's dive into it. Firstly, what do we mean when we say logic? Well, logic, put simply, is the study of arguments. That is the most basic definition to it. Now, you will find more complicated definitions online. However, at the very core of it, logic is the study of arguments. But if logic is the study of arguments, well then, what are arguments? What do we mean when we say that logic is the study of arguments? Well, put simply again, arguments are simply a series of statements, namely some series that are named premises that lead to other statements named conclusions. Now that we have provided this definition, there is another question to be answered. What are statements? What do we mean when we say that arguments are a series of statements? Well then, let's look at statements. A statement is a sentence that is either true or false. Now you might think, aren't all sentences either true or false? Well, no, and we'll see why. Let's look at this first sentence right here. This first sentence right here is telling us that my name is Rad. Now this sentence right here can either be true or it can be false. I can lie by saying that my name is Rad. It all depends on whether or not my name is indeed Rad or not. But then let's look at this other sentence right here. Let's go get ice cream. This is also a sentence, but can I say the truth by saying let's go get ice cream? Can I lie by saying let's go get ice cream? Well, it seems no. And the reason for that would be that a sentence that is a command, such as let's go get ice cream, does not have a truth component to it. Another sentence that is similar in nature in the virtue that it does not have a truth component to it is a question. If I ask, do you want to go get ice cream? Again, I cannot lie using a question because questions do not have a truth component to it. Now that we understood the basics of logic, let's go into the very first component of it, which is statements. And after we learn more about statements, we can then build our way up through arguments and understand logic at a very basic level. So we already know that statements are just declarative sentences, meaning that they have a truth value to them. For true sentences, like my name is Rad, we call those statements affirmation statements. As you can see, there is no symbol here, and again, these are affirmation sentences. There are no symbols here, and the word that can help you distinguish an affirmation statement from others is simply the word is. If you see is, like my name is Rad, that ball is red. These are sentences, these are statements that are affirmation statements. Now again, these are statements that assert something to be true. However, there are also statements that assert something about the world is false. For those statements, we call those negation statements. Now, you'll see here that negation statements do have a symbol, as you can see with this little line right here. If you see that line behind another symbol, namely P here, how it reads out is that not P. So, for example, in this case, Rad is not a student. It is asserting that something in the world is false. It is false that Rad is a student. Therefore, Rad is not a student. The word that will help you distinguish negation statements from other types of statements is the word not. Now let's look at the next type of statement that we have. We have statements called conjunction statements, and they're symbolized by this half-complete triangle that says, or like an upside down V, that says P and Q. An example of a statement that would be a conjunction statement would be Rad is a student and an athlete. Now, mind you that in order for this statement right here to be true, it needs to be the case that Rad is simultaneously a student and Rad is an athlete. If only one of those is true, for example, if Rad is a student but he's not an athlete, then this statement right here is also not true. Also, if both of these, if both halves of the statement are not true, being that Rad is not a student and Rad is not an athlete, that also means that this statement is not true. Some statements that we have that are very close to conjunction statements are disjunction statements. They're symbolized by something that looks like a V. It is essentially the same symbol as conjunction, except it is upside down. And this right here reads as P or Q. So an example of it would be either Rad is a student or a lawyer. So as you can see, the word either and the word or are the two words that distinguish disjunction statements from other types of statements. And another thing to know here is for this statement right here to be true, one of two things can only happen. Either Rad is a student but he's not a lawyer, or Rad is a lawyer but he's not a student. If Rad is both a student and a lawyer, then this statement right here is false, because only one of them can be true at the same time. On the same note, if Rad is neither a student nor a lawyer, this statement will be false again, because Rad needs to be at least one of those two things. Now let's dive into the statements that we will be covering more in depth today, starting with conditional statements. Now, these are statements that you often hear in day-to-day life. You always hear people saying, "Oh, if I am mad, then you need to apologize to me. If this, then that." These are called conditional statements, being that there's a condition for something else. They're symbolized by an arrow. If you see P having an arrow in front of it that leads to Q, this reads out as if P, then Q. An example would be, if Rad is a lawyer, then he is rich. Now, similarly, another type of statement we will be looking at, which is very similar to a conditional statement, is a biconditional statement. So they are symbolized by an arrow leading both ways. So if you see there's P first with this kind of arrow followed by Q, this reads out as P if and only if Q. An example of a sentence that would be a biconditional sentence would be, a statement would be, Rad is a lawyer if and only if he has graduated from a law school. Now we will be looking more deeply at what implications if and only if has and how it is different than merely if then. But for now, before we get into conditional and biconditional statements, there are some things that we need to know first. The thing that we need to know before we move on to learn about conditional statements is that they take form in an if-then form, as we saw before. So we saw that the example that we just had is if Rad is a lawyer, then he will be rich. Now, the if statement is the first part of it, which says, for example, if Rad is a lawyer, that is known as the antecedent. So again, antecedent is the first part of a conditional statement. So in the statement, if Rad is a lawyer, then he will be rich. If Rad is a lawyer, that is the antecedent. And then the then statement part of it is called the consequent. So then the part that says, then Rad will be rich, that is known as the consequent. Now, the reason I bring up the antecedent and the consequent is that it is crucial to understand that the relationship between the antecedent and the consequent has nothing to do with its temporality. So what I really mean is that we're not putting them into the order that they are because one comes before the other in terms of time. It is simply and merely just about their relationships in terms of conditions, what kind of conditions there are to each other. So to really pan out how that looks like is, let's say that I'm a person who hates umbrellas. And the only way that I will ever use an umbrella is if it is raining really badly. Now, when I tell you that, you might intuitively think that the corresponding conditional statement would be, if it is raining really badly, then I will bring an umbrella. However, this will be false. And I should note, the reason you're thinking this is because it rains first, then I bring an umbrella. And also, it raining really bad is what causes me to bring an umbrella. It's not that the clouds look at me, pull out an umbrella, and suddenly they decide to rain. It's that once I see the rain, I decide to bring an umbrella. So then, because of those two facts, the temporality and causality, you might think that the order that they are put in, namely the fact that it raining really badly being before an umbrella, might have to do with that. However, that is not true, as we will see. As you can see, this statement is not the corresponding conditional statement to the scenario I just described, because let's say I bring an umbrella on a sunny day. Well, then the conditional statement would still hold. However, the scenario that I just described is that I'm a person who hates umbrellas. The only way that I will ever use an umbrella is if it is raining really badly. So we want the conditional statement to represent that. Therefore, the correct conditional statement would be that if I bring an umbrella, then it is raining really badly. Now, you might still be a little bit confused between what the difference between the first example that we had right here is with this one. Obviously, you can see that the order is different, but to see more about how these two statements are different, not just in expression, but also in logic, we will be taking a very quick intro into what necessary and sufficient conditions are. So the term condition itself, generally when we say that X is a condition for Y, we mean that if X happens, then Y will also happen. So for example, let's say your friend is mad at you, they will tell you that they will forgive you on the condition that you buy them flowers. So if you buy them flowers and you make the first part happen, the second part will happen too, and they will forgive you. However, that is a bit too ambiguous for logic. Logic is more specific. So that is why we have two types of conditions. We have necessary and sufficient conditions. So just to throw the definition out there, the definition, just to explain what a necessary condition is, if Y is a necessary condition for X, then X will only happen if Y happens. And X happening necessarily means that Y also happens. On the other hand, for a sufficient condition, if P is a sufficient condition for Q, then all that we need to know for Q to happen is for P to have happened beforehand. Also, P happening is sufficient for us to know that Q has also happened. Now, it might be a little confusing about what these definitions are, but as we will see right now with some real examples of sufficient and necessary conditions, you can see how they pan out here. Here's a following example to really understand what a necessary condition is. Let's say you want to take a driving exam. They all have a fee that you must first pay in order to get your driver's license. And this fee that you must pay to the exam center is a necessary condition for you to take a driving exam. However, paying the fee is not a sufficient condition to take the exam, as it is possible that somebody pays a fee but will be unable to take the exam because they failed to fulfill another necessary condition, such as having a car. So then in that light, a necessary condition is just simply a condition that must happen for the other outcome to occur. It must be the case that you pay a fee for you to take the exam. If you do not pay the fee, you do not have an exam. Similarly, if you do not have a car, then you cannot take the exam because it is a necessary condition and you failed to obtain it. Now let's look at sufficient conditions. Here's the following example to really demonstrate and visualize what a sufficient condition is. For you to get sick, it is a sufficient condition for you to drink expired milk. What I mean is that you drinking expired milk is sufficient for you to become sick. So that means all that you need to do to become sick is just drink expired milk, of course past a certain quantity. However, since drinking expired milk is not a necessary condition to becoming sick, it is possible that somebody will be sick without having previously drank expired milk. Because it is not the case that you must have drank expired milk for you to become sick. That's in cases with a necessary condition. But if all you need to do, the only condition you need to obtain to become sick is drinking expired milk. However, there are also other ways to become sick. Now that we understand and know what necessary and sufficient conditions are a little bit more, let's see what they look like in a conditional statement. Namely, how they look like when we introduce the terms antecedent and consequent. So in a regular conditional statement, the antecedent is a sufficient condition for the consequent, while the consequent is a necessary condition for the antecedent. So let's see what this looks like. Firstly, let's take this example, this statement. If Rad brings an umbrella, then it is raining really bad. So what is the antecedent here? The antecedent is if Rad brings an umbrella. The consequent is it is raining really bad. How do the sufficient and necessary conditions play? Now, it raining really badly, naming the consequent, as you see, it raining really badly, and the consequent is necessary for Rad to bring an umbrella, namely the antecedent. Now, what that tells us is that unless it rains really badly, then Rad will not bring an umbrella. And the reason for that is that it raining really badly is necessary to happen for Rad to bring an umbrella. On the other hand, Rad bringing an umbrella is sufficient for it to be raining really bad. Again, Rad bringing an umbrella is the antecedent, and the antecedent is sufficient for the consequent, namely it raining really bad. If Rad brings an umbrella, then it must be the case that it is raining really bad because it is sufficient for it to be raining really bad just based on the knowledge that Rad has brought an umbrella. Now the situation here completely flips around when we move on from an if-then statement to an only if-then statement. So in an only if-then statement, the part that says only if is a necessary condition for the part that says then. And then the part that says then is a sufficient condition for the part that says only if. this relationship was the opposite when instead of only if, it was just if. Now, an example that you can see is this statement right here. The statement would be, only if Sarah understands the material well, then Rad is deemed a good teacher. Well, here, the only if part, which says that Sarah understands the material well, is necessary for Rad to be deemed a good teacher. Meaning that unless Sarah understands the material well, then Rad is not a good teacher. On the other hand, the then part that says Rad being deemed a good teacher is a sufficient condition for Sarah to understand the material well, namely the only if part. What that means is that if Rad is deemed a good teacher, it must be the case that Sarah understands the material well. Now, one thing that you might notice here is that I did not introduce the only if part as the antecedent and the then part as the consequent. And the reason for that is that the antecedent must always be a sufficient condition to the consequent, and the consequent must always be a necessary condition to the antecedent. Now, I know that earlier on I introduced the antecedent and the consequent as one being the part that has the if in it, and then the other one being the part that has the then in it. While that is true generally for most conditional statements, when we take if and we change it to only if, that actually flips around which part of the statement is the necessary condition for the other, and which part of it is the sufficient condition for the other. As a result, we will actually have something like this. The consequent will be the part that has the if in it, not because it says if, but because this half of the statement is necessary to this half of the statement, and this half of the statement is sufficient to this part of the statement. So because this half is a sufficient condition to this half, that means this part is the antecedent and this part is the consequent. On the other hand, because this part is a necessary condition to this half, that means that this half is the consequent and this half the antecedent. Now let's look at what happens when we're dealing with biconditional statements. So if you remember correctly, a biconditional statement is something that says if and only if. So again, we're gonna refrain from using the terms antecedent and the consequent just yet. And what really happens is that in a biconditional statement, both halves of the statement are both the antecedent and consequent, meaning that they're both necessary and sufficient to each other. And what that implies is that either both conditions obtain or none of them do. So to illustrate, let's look at this example. Rad is a lawyer if and only if Rad has graduated from a law school. Now, in this statement, either Rad is a lawyer and a law school graduate, or he is not a lawyer nor a law school graduate. Both parts of the statement, being both this half and this half, both necessitate each other and suffice for us to know that the other one has occurred. And one thing to note real quick is that the reason they're both the antecedent and the consequent to each other is because all that antecedent means is being sufficient for the consequent, and all that consequent means is it being necessary for the antecedent. So since both halves of the statement are both necessary and sufficient to each other, that means both play the role of the antecedent and the consequent relative to each other. So as a result of this, the two halves can actually change places without the meaning changing at all. The expression will change linguistically, but in terms of logic, there will be zero difference at all. So, for example, if I say Rad is a lawyer, if and only if Rad has graduated from a law school, that means the exact same thing as saying Rad has graduated from a law school if and only if Rad is a lawyer. Because it does not matter how we order these two halves of the statement, because they're both necessary and sufficient to each other. So it does not really matter which side of the if and only if they are on. And before we really move on, there's just one thing to know here very quickly, and that's that what does if here mean? Right here when we say if, what we really just mean, this is not really that important, but it stands for if and only if. So if you're ever reading philosophy and you see a statement that says if with two f's on it, that is not a typo. It is deliberate and it is meant to be a shortened version of if and only if. So now that we learned what statements are and we're more comfortable with them now, let's look at arguments, which are the products of statements. So as we said before, arguments are a set of statements, some of the statements being premises and the others being conclusions. Now you will often see that arguments are presented in the form of a syllogism, otherwise known as a premise conclusion form. Here's an example. So here's the example of a syllogism. Socrates is immortal, that is premise 1. Premise 2, all humans are mortal. Premise 3, therefore Socrates is mortal. Now if in your philosophy readings you ever notice a form of text being written listed like this, with the last line or the last few lines having a therefore symbol right there, that is not a list or anything. That is actually a syllogism. That is an argument that the author is trying to make. And to really break down what it means, statements 1 and 2, which are color coded in red right here, these are called the premises. And a premise is a statement, meaning it is either true or false, as we demonstrated before on what that actually means. And you will notice that there will be a few lines. It can be one, it can be few. Usually it is a few lines that lead up to a final line that starts with a therefore symbol. This third premise right here is called a conclusion, and it is deducted from the first two premises, meaning that it must be the case. If premise 1 and 2 are the case, it must be the case that premise 3 is also the case. And it is not necessary for the conclusion to only be one line. You can have the conclusion be multiple lines, and it is not necessary for the premises to be multiple lines. You will have premises that are just one line. Now let's see what we are mainly concerned with when we're handling arguments. Arguments are often categorized by how effective they are. So they can either be valid, they can be sound, or they can be neither one. So starting with valid arguments, an argument is valid if and only if it is impossible for its premises to be true. So two things to know here, one being the wording of if. We just learned that it was if and only if. What that means that it being impossible for the argument's premises to be true and the argument's conclusion to be false is a sufficient and necessary condition for us to deem an argument valid. We don't need anything else. That's all that is needed for us to consider an argument valid. And the other thing that we should really pay special attention to here is when it says and, right? Again, as you remember, this is a bit of a conjunction statement, meaning that for it to be true, both halves, one being its premises to be true, and the other half being its conclusion to be false, you need both of those to happen simultaneously. So when we say that it is impossible for its premises to be true and its conclusion to be false, that means it is impossible at the same time for both its conclusion to be false and its premises to be true. So here are some examples of valid arguments. The first one is the one on the left hand side. Socrates is a human, all humans are mortal, therefore Socrates is mortal. Mind that it is impossible for these two to be true while the conclusion is false, right? Therefore, this is a valid argument. And now let's look at this one right here. Plato is a butterfly. All butterflies live in the ocean. Therefore, Plato lives in the ocean. Now, this might sound gibberish to you because all the statements are they're completely false. But you must note that we are not concerned with whether a statement is true or not. As you remember, if and only if it is impossible for the premises to be true and its conclusion to be false. The content does not matter at all. It is just a hypothetical of, is it possible for these two to be true and this one to be false? Well, although it isn't true that Plato is a butterfly, and although it isn't true that all butterflies live in the ocean, it is still impossible if we were to disregard these two to be true while this one to be false. There's no possible world where Plato is a butterfly and all butterflies live in the ocean while Plato doesn't live in the ocean. And that is why this one is a valid argument too. So now let's look at what it takes for an argument to be sound. By definition, an argument is sound if and only if the argument is valid and the argument's premises are true. So not only are we concerned with the logical structure of the argument, but we're also concerned with the content to see whether or not the actual premises are true or not. Now we've already established that both these arguments are valid arguments. Therefore, they both pass the first criterion. Now let's assess the second level for an argument to be deemed sound. Are the premises true? Well, we see that on the argument over here, yes, it is true that Socrates is a human, and it is true that all humans are mortal. Those are the premises. That's all I need to be concerned with. I don't need to look at the conclusion because I know that it is, as long as these two are true, it is impossible for the third conclusion to be false. So yes, it is true that Socrates is human, and it is true that all humans are mortal. Therefore, this argument on the left-hand side is a sound argument as well as a valid argument. But let's look at this one right here. We have assessed that it is a valid argument, but let's look at the premises. Plato is a butterfly. That is not a true statement. All butterflies live in the ocean. That is also not a true statement. So what this means is that this argument on the right hand side, although it is valid, its premises are not true. And its premises being true was a necessary condition for this argument to be deemed sound. And therefore, this argument is only valid and not sound. So when we're assessing an argument, we only need to ask ourselves two questions, and those are the following. The first question is it impossible for the argument's premises to be true and its conclusion to be false? So this you have heard this wording before. This is just a definition for a valid argument. So essentially, the first question is the argument valid? The second question is, are the argument's premises true? And the answers to these questions give us the answer to whether or not an argument is valid, or is it sound, or is it neither one. So if only the answer to number one is yes, and the answer to question two is no, then you have a valid argument. If both the answer to question one and question two are yes, then you have a sound argument. If the answer to question one is no, you have neither a valid nor a sound argument. So let's put our method to test and let's assess the following arguments. So the first argument that we have is Bruce Wayne is a bachelor, therefore Bruce Wayne is unmarried. Well, the first question that we need to ask is this argument valid? Well, by definition, it is impossible for it to be true that Bruce Wayne is a bachelor, while it being false that Bruce Wayne is unmarried. Therefore, yes, it is valid. And we're going to look at, are its premises true? Remember, it only has one premise, so this is the only sentence that we're concerned about. Is Bruce Wayne a bachelor? Yes, Bruce Wayne is. That statement is true. Therefore, our first argument is a sound argument. Next, we have this argument. If I press the brakes, then the car will stop. I press the brakes, therefore the car will stop. So let's ask ourselves, is it valid? Well, yes, it is. It is impossible for the premises to be true while the conclusion is false. Now let's ask, are the premises true? Well, if we're being fair in general here, yes, the premises are true. It is true that if I press the brakes, then the car will stop. That's of course if you want to assume that the car is in the air falling off a cliff, then yes, the car will not stop, making this statement not true. But we just want to stay just general here, and we're just going to stay fair, so we're going to assume that this is true. And the second one, is it true that I pressed the brakes? Well, yeah, I did press the brakes. Therefore, the answer to both questions is yes, and we have another sound argument. Now let's look at this third argument right here. Wolves are animals. All animals are mortal. Therefore, wolves have tails. Well, let's assess the argument. Is it valid? Is it impossible for its premises to be true while the conclusion is false? Again, remember, the content is not what we're worried about here. You might be misled to think that this is a valid argument because it is impossible for wolves to be animals and animals to be mortal, while wolves while wolves do not have tails. You might think that because these are all true facts, but again, remember, for validity, the truthiness does not matter at all. It is not impossible for wolves to be animals and all animals to be mortals, while it being false that wolves have tails. So the answer to the first question is no. I do not even need to go and ask myself whether the premises are true or not, because well, they are true, but that does not matter at all, because the answer to the first question was no. If the answer to the first question is no and the answer to the second question is yes, that is as good as an argument that says no to both questions. So now let's assess these arguments. Aristotle is a human. All humans can fly. Therefore, Aristotle can fly. Well, let's see. Is it valid? Yes, it is. It is impossible for Aristotle to be human and all humans to be able to fly, but Aristotle wouldn't be able to fly. As long as the premises are true, the conclusion must also be true. It is impossible for it to be otherwise. So it is valid, but is it sound? No, it is not, because one of the premises is not true. All humans cannot fly. It is not true that all humans can fly. Let's look at the next argument. Descartes is alive and Descartes is dead. That is one premise. The conclusion is, therefore, Kant can fly. Well, do you think this is a valid argument? Let's see. Let's go back to our definition of what a valid argument is. Again, an argument is valid if and only if it is impossible for its premises to be true and its conclusion to be false. So again, remember, this is a conjunction statement. And in this case, look at premise 1. A premise 1 is what we call a contradiction. It is impossible for a contradictory statement to be true. It is impossible for Descartes to be alive and Descartes to be dead at the same time. And since that is the only premise, it is indeed impossible for the argument's premises to be true and its conclusion to be false, just by the virtue of the fact that it is impossible for the premises to be true. So although it might seem very counterintuitive, this argument is indeed valid. But now let's ask ourselves, are its premises true? Well, again, is this statement right here true? Descartes is alive and Descartes is dead? Well, no, it is not a sound argument, because again, this is a contradictory statement. The whole point was that it is impossible for a statement of this nature to be true. Now let's look at the last argument. Premise 1 says that Kant can fly, and then the conclusion is that therefore either Descartes is alive or Descartes is not alive. Now let's ask ourselves, is this a valid argument? Well, let's go back to the definition. If and only if it is impossible for its premises to be true and its conclusion to be false. Now let's look at the conclusion right here, right? It is supposed to be impossible for this conclusion to be false. That is a necessary condition. That is a sufficient condition for it to be a valid argument. It is indeed impossible for this statement to be false. This is again a statement that is true by definition. Everybody is alive or not alive just by definition, and therefore it is impossible for this for the conclusion to be false. And just by the virtue of it being impossible for the conclusion to be false, we have another valid argument. And are its premises true? No. Immanuel Kant cannot fly. So now that we know more, about arguments, especially about the validity and the soundness, let's look at something called the rules of inference. So what are rules of inference? In short, rules of inference are just some rules in logic that you simply have to accept. There's a famous quote that says, logic will take you by the throat and force you to accept these rules. Now, what are these rules? The two main rules of inference concern specifically with conditional statements are firstly being modus ponens and the other one being modus tollens. Now this might sound a little confusing, but we will be looking at them more in depth in a bit. But let's also talk about some fallacies. Fallacies are mistakes made in logic. We're trying to avoid them. And two very common mistakes that happen specifically concerning conditional statements they are called affirming the consequent and the other one being called denying the antecedent. So let's start with modus ponens. Modus ponens, also known as affirming the antecedent, is essentially a rule of inference that dictates that in a conditional statement, if the antecedent is true, then the consequent must also be true. So in an argument that we see, if P then Q, let's say it is true that it is P, therefore it must also be true that it is Q. So if P then Q, P, therefore Q. Let's look at a more vivid example. If Rad brings an umbrella, then it is raining really bad. Again, this is the antecedent, this is the consequent, and this is a conditional statement. Let's say it is true, the antecedent is true. It is true that Rad brings an umbrella. Therefore, it must also be true that it is raining really bad. In other words, the consequent must also be true. A quick note about modus ponens is that modus ponens shows that in a conditional, the antecedent is a sufficient condition for the consequent. So again, as I've been saying, the antecedent, if that happens, the consequent must also happen, because all you need for the consequent to happen is the antecedent happening. Moving on, let's look at modus tollens. Modus tollens is also known as denying the consequent. Essentially, modus tollens dictates that in a conditional statement, if the consequent is not true, then the antecedent must also not be true. That is, if P then Q, which is a conditional statement, let's say not Q. It is not the case that Q is true. That means, therefore, it must also be the case that P is also not true. Let's see a more vivid example. Again, with the statement, if Rad brings an umbrella, then it is raining really bad. That is a conditional statement. Again, this is the antecedent, this is the consequent. Let's say that the consequent is not true. It has not obtained. That is, it is not raining really bad. Well, if the consequent is not true, then the antecedent must also not be true. If it is not raining really bad, then that means that Rad does not bring an umbrella. And what modus tollens really tells us is that in a conditional statement, the consequent is a necessary condition for the antecedent, meaning that unless the consequent obtains, the antecedent cannot obtain. So now let's look at some of the fallacies that we have been talking about. Again, fallacies are mistakes that happen in logic and are not permitted. When we say affirming the consequent, we're referring to thinking that just because the consequent is true, then the antecedent must also be true. That is, someone might mistakenly take the following argument to be true. Let's say that if P, then Q. That is a conditional statement. And let's make the consequent true. Let's say it is the case that Q. Someone might mistakenly think that this suggests that P is also true. This is a logical fallacy. We can see why here. Let's all give a more vivid example. If Rad brings an umbrella, then it is raining really bad. Again, a conditional statement. Let's make the consequent true. Let's make it true that it is raining really bad. Does this infer that Rad brings an umbrella? No, it does not. Again, the reason for that is that the consequence is not a sufficient condition for the antecedent. It is a necessary condition. What I mean is that it is not sufficient for us to assume that Rad brings an umbrella just because it is raining really bad, which is the mistake that we have made by in affirming the consequent fallacy. Let's look at the other fallacy, which is known as denying the antecedent. By denying the antecedent, we're referring to thinking that just because the antecedent is not true, then the consequent must also not be true. So it will look like the following. If P then Q, let's say that is a conditional statement, let's say that it is the case that it is not P, that P is not true. Someone might mistakenly infer that therefore not Q. However, this would be a logical fallacy. Again, let's look at a more vivid example. If Rad brings an umbrella, then it is raining really bad. That is our conditional statement. Let's make the antecedent not true. Let's make it not true that Rad brought an umbrella. Therefore, our premise 2 is Rad does not bring an umbrella. Someone might mistakenly think that, oh, if Rad did not bring an umbrella, that means that it is not raining really bad. However, that would be a logical fallacy because the antecedent is not a necessary condition for the consequent. So to use this example, Rad bringing an umbrella is not necessary for it to be raining really bad. So if Rad is not bringing an umbrella, that does not mean that it is not raining really bad. However, Rad not bringing an umbrella, that is the antecedent, is a sufficient condition for the consequent. Now that we have covered what arguments are and what statements are, let's quiz ourselves using some logical exercises. The first exercise is going to be counterexamples. So what are counterexamples? A counterexample is an example that disproves a statement. So a counterexample is what it takes for a statement to be false. So take this statement. This statement, if Rad brings an umbrella, then it is raining really bad. What does it take for this statement to be false? Well, this statement would be false if one day we were to see Rad bring an umbrella when it is not raining really bad. If this happens, then the statement, if Rad brings an umbrella that it is raining really bad, is false. So the reason we learn counterexamples is because they help us better understand philosophical arguments, and more specifically, they help us object to them. If some philosopher in his paper is trying to argue that the following statement, that if Rad brings an umbrella, that it is raining really bad, you can just completely object to them and say, wait, that is not the case. The other day, I saw Rad bring an umbrella when it was not raining really bad. Therefore, the argument that you're proposing is not true. The statement that you're giving us is completely false, and therefore you have effectively objected to them. So let's try some of these ourselves. Let's take the statement, if I am hungry, then I get mad. What does it take for that statement to be false? Is it A, I get hungry and then I don't get mad? Does it take for me to be hungry but me not getting mad? Or is it C, I do not get hungry but I get mad? Or D, I do not get hungry and I do not get mad? So you guys can pause the video to wait and think about the answer yourself, but I'll reveal it right here. It is B. What does it take for if I am hungry then I get mad to be false? If someone tells you if I am hungry then I get mad, you can say, well, no, the other day you got hungry but you did not get mad. That is an effective counter example. Now let's look at this statement. Only if a call is important, then I will answer it. Again, you can pause the video, but here's the answer. What would it take? What would be a counter example? It would be a time, if I tell you only if a call is important, then I will answer it, you can say, well, no, a call wasn't important the other day, and you answered it. So that's what it would take for that statement to not be true. Now, you might have thought that the counterexample will be time that a call is important, but I did not answer it. But you have to remember that a call being important is necessary for me answering the call, but it is not sufficient to make me answer it. Now let's look at this statement. I will get an A if and only if I study hard. Now this one comes with two answers, because as you remember, we can take if and only if statements and create two statements that mean the exact same thing with them. So let's see what the counterexample to this one is. Again, two answers. Well, the first one, if someone tells you I will get an A if and only if I study hard, you can say, well, that's not true. Our last test, you got an A, but you did not study hard. Or you can tell them, or our last test, you did not get an A, but I remember you studied really hard. So then again, those would be effective counterexamples. So now let's look at contraposition. Each conditional statement also has a contrapositive that has the same logical meaning but a different form of expressions. So that's all that contrapositives are. It's flipping a conditional statement into a different form of expression while it keeps the exact same logical meaning. So to show you what that looks like, I will give you this example. If I drink wine, then I will get a headache. The contrapositive would be, if I do not get a headache, then I did not drink wine. Again, this has all to do with necessary and sufficient conditions, because if you know this, it is sufficient for me drinking wine is sufficient for me to get a headache. Meaning that if it was the case that I drank wine, it must have also been the case that I got a headache. But if I wake up one morning and I do not have a headache, then I can conclude that I did not drink wine. Now, as long as the original statement is true, then the contrapositive must also be true. So it cannot be the case for you to say that if I drink wine, then I will get a headache, but it is not the case that if I do not get a headache, then I did not drink wine. Again, if the first statement is true, then the second statement, the contrapositive, must also be true. Another thing about contrapositives is that they help us better understand modus tollens, hence allowing us to better understand some philosophical arguments. So just to demonstrate how we learn more about modus tollens this way, is just take this statement right here. If I drink wine, then I will get a headache. Again, this is the antecedent, this is the consequent. Remember that modus tollens was denying the consequent. So let's say that it is not true that I got a headache. As you can see, there's a case right here. What happens if I don't get a headache? If I don't get a headache, modus tollens tells me that I did not drink wine. Now, let's look at all these statements here. The statements are on the left-hand side. You can try and think of the contrapositives. Again, just to make it easier, for example, for this one, all you have to do is take the consequence and then deny it and see what happens. I will be moving through these quite quickly, so I do encourage you to pause the video to give yourself some time to think. So the first statement is, if a student attends University of Toronto, then they live in Canada. The contrapositive is, if someone does not live in Canada, then they are not a student at the University of Toronto. The second one is, if a triangle is an equilateral, then all of the triangle's interior angles are equal. The answer would be that if all of the triangle's interior angles are not equal, then the triangle is not an equilateral. The answer to the third question is, if a shape does not have 4 equal sides, then it is not a square. The fourth one being, if Sarah does not understand the material, then Rad is not deemed a good teacher. And with the last example, again, this is a statement that uses if and only if. And if you remember, if and only if can be, you can write two statements that have the exact same meaning with them. Therefore, they will actually have two contrapositives. And what the answer to that will be is, firstly, if Rad is not a lawyer, then he's not a law school graduate. And on the other hand, if Rad is not a law school graduate, then he is not a lawyer. Again, there's a subtle difference, yet important difference between the two answers there. Let's move on to the next exercise, and that will be logic translations. So when we're doing logic translations, we're doing something very simple. We're taking a sentence from regular English and translating it into a logical system. Namely, in this exercise, we're turning it into a conditional statement. So let's take the following regular sentence. Let's take the sentence that all dogs bark. Well, the logic translation for that would be that if it is a dog, then it barks. So then again, remember, it is when we say that all dogs bark, that means that it is necessary for a dog to be barking. For something to be deemed a dog, it must bark as well, which gives us this statement. And then the next statement would be, you are not allowed to drive without a license. The logic translation would be, if you are allowed to drive, then you have a license. Again, it wouldn't be the other way around, saying that if you have a license, then you are allowed to drive, because again, we're mistaking the necessary and sufficient conditions between the two here. Now, we learn logic translations because they help us better understand the relationship between the antecedent and the consequent. And practicing them will actually help you understand their questions better, and they are also a component of some standardized tests, such as the LSAT. So let's quiz ourselves. The first one says that you need at least an 80% on the exam to pass the course. So if your teacher tells you that, what does that mean? That means if you pass the course, then you got at least an 80% on the exam. Let's say scientist tells you that all plants use water as food. What does that tell you? That tells you that if it is a plant, then it uses water as food. The answer to the third one would be that if someone is a good teacher, then they explain the material well. The answer to the fourth one is, if a sandwich is good, then it does not have olives. Fifth one being that if someone is a good student, then they have good time management skills. The fifth one being that if you study before your exam, then you will succeed on your exam. And lastly, when we say that the song will play after you click start, that means if you click start, then the song will play. Now, if you want some further exercises, you can try to find the corresponding contrapositives and counter examples to the statements that we just created from the previous exercises. For example, we created all of these statements from the exercise beforehand, and to show you how it works, I'll just give you an example with the first statement right here. If you pass the course, then you got at least an 80% on the exam. So what's the contrapositive to that? Let's make this side not true. Let's make it not true that you got at least an 80% on the exam. Well, if you did not get at least an 80% on the exam, then you did not pass the course. That's simple. If the consequent is not true, the antecedent is not true. That is the contrapositive. Now let's look at a counter example. The counter example will be, for example, if your friend, let's say James, to your right, actually passes the course without having had an 80% on the exam, that would be a counter example. And then you can bring that up to your teacher and say that your policy is not correct, you're lying on the syllabus, and it is not true that if you pass the course, then you got at least an 80% on the exam. And that really wraps us up for this video. In summary, we went over what logic is, namely what do we mean when we say logic, and some definitions of statements and arguments. And speaking of statements, we went over to what they actually are, what the different types of statements are. In order to understand statements, it was necessary for us to understand sufficient versus necessary conditions. And finally, we delved more deeply into what conditional and biconditional statements are. Then we moved on to arguments. We learned what valid arguments are, what sound arguments are, and and what arguments that are not valid nor sound look like. We went over some rules of inference, namely modus tollens and modus ponens, and finally we went over some common fallacies. And at the end, we went over some logical exercises, namely counterexamples, contrapositives, and logic translations. And after that, that is all for this video, and I hope you guys enjoyed the lesson.